Hi there, this is Mr. Bainey. Thank you so much for watching my video. We're going to take a look at lesson 9.2, properties of reflections. The standard up at the top right is 8.G.1b, and our essential question is, how do you describe the properties of reflections and their effect on the congruence and orientation of figures? So orientation and congruence is something I talked about in the previous video. I will mention some orientation for sure in here because it's much more important. So some vocab for you is a reflection is our second type of transformation. Remember that our first one is called translation in 9.1. And a reflection means that we're going to flip a figure across a line, and that line is called the line of reflection. So taking a little closer look at our vocab words here, the line of reflection, I want you to think of that as like a mirror. So we're flipping something, and if you can imagine you looking at yourself in the mirror, you yourself are the pre-image, and what you see in the mirror is your reflection, right? We call that the image. And so that's essentially what's going on when we're dealing with shapes in a graph. Okay, so let's take a look at, I'm not actually going to do this explore activity. I do want to demonstrate what happens when you do a reflection, but this explore activity is actually good if you want a better visual, and actually you can do it yourself by taking a piece of paper and then doing some folding, right? Just follow the directions. If you would like another visual, it's a little bit difficult to show you in this video, but I could show you another one if you want to come in and ask me some questions. Okay, so let's take a look at this triangle here in the graph, triangle ABC. If I were to take this and flip it from left to right, I'm sorry, from right to left, so let's say I wanted to flip this triangle over the y-axis. So I'm going to draw a red line here on the y-axis, and this means that this is my mirror. So think about what it looks like if this triangle was looking at this mirror, this red line right here. This means I'm going to take this figure and I'm going to flip it onto the other side of the mirror. Okay, so everything on here is going to be the same distance to the mirror on the other side. So this is what it's going to look like. So let's flip. I go left to right, and then it's going to go to the other side over here, and I get this shape. So this becomes triangle A prime. B prime is way over here, and C prime. Okay, so if I draw a line connecting our image and our pre-image, I get something like this. Okay. And so all these points from A to A prime, from B to B prime, and from C to C prime are the same distance to the mirror as same distance as each other to the mirror. Which is super important. So that's if you use the y-axis as the mirror. So let's undo all of that, and then we'll see what this looks like if we do the x-axis as the mirror. So if I want to do the x-axis, let's draw our red line now on the x-axis. That's the one going from left to right. If that's our new mirror, then we want to first think about, visualize what that's going to look like if I take this and flip it across the x-axis. So it's going to be like in this area right here, and all of the points, for example, point C is only 2 points away, two boxes away from the mirror, which means on the other side, point C prime will be right there. Yeah, that's where the image is going to be. So let's show you this in action. If I flip this, and then it's going to go down here. that it's what it will look like, and I have point A prime is actually going to be here at the bottom, right? Because A is the furthest point away from the mirror. There's C prime and there's B prime. Okay, some important things to notice here. Let me have you think about a couple questions. Does the triangle ABC and A prime, B prime, C prime, are those two triangles the same shape and are the same size? So hopefully you're thinking yes to both of those. They are the same shape and same size, which means they are congruent. So same shape and same size. Okay, those two things mean congruent. And then the other thing that was mentioned in the essential question is the orientation. So you want to think about, especially compared to translation, right? If you understand translation from lesson 9.1, now the orientation of ABC means that it's right now the A is on top of the triangle, the B is on the right side. And so when you look at this one, does it have the same orientation? Is it all facing the same way? And no, it's not. So we say it has the same shape and the same size, which means congruent, but they have a different orientation. Okay, so I'm going to write up here at the top, near the top of the graph, that the orientation changes. Okay, it's an important observation we make from reflections. Okay, so the Explore Activity 2 is also another good one to try out for yourself, but what I do want to show you is you actually reflecting this. So let me trace this trapezoid as best I can, and then let's go ahead and try to move these. So I'm going to show this trapezoid reflected across the y-axis. So remember, the y-axis is let's use a highlighter here, is this one going up and down. So think of that as my mirror, and if I were to take this trapezoid and then flip it, so let's flip it, if I'm flipping it over the y-axis, I'm flipping it from left to right. So it's going to look like that, but going across our mirror so that everything is the same distance to the mirror. And so I'm going to have T prime is going to be here, R prime, A prime, and P prime. Okay, so doing, again, one point at a time. So notice that it is the same shape, the same size, but it is a different orientation. Okay, and the two shapes are congruent. Let's take a look at just one example that we have one your turn that we can take a look at. Number 4, we have a pentagon, ABCDE, and we want to graph the image of the pentagon after a reflection across the y-axis. I'm not going to actually show this in action, instead show you how you would do it, or how you could think about it if you were to just move each point one by one. So the y-axis is this one, again, it's the one that's going up and down. So this is going to be our mirror. Let me go ahead and mark that down. Here's our mirror. So let's do each point separately. So think about point A. Let's start there. How far away is point A to the mirror, going directly to it? So I'm going to count over 1, 2, 3, 4, and 5. So I'm going to count from my mirror going the other way. 1, 2, 3, 4, and 5. And so that end up being right here. In this point, let's use a different color. Point A prime is going to be that. So remember, point A prime is the image of A. And then if I go to the next point, is point B, it is 3 away, which means B prime is going to be 3 away on the other side of the mirror. Then point C is 2 points away from the mirror, which means from this part of the mirror going 2 points the other way is going to be my point C prime. And then on the bottom, point D is 3 away, so going directly across will give me D prime, going 3 away from the mirror. And then lastly, E prime will be right here. Okay, so remember, what I do know is that if I were to draw this after plotting the points, I should get a new shape, my image, that is the same shape and the same size, but it's going to be a different orientation. That's every time I reflect it, it'll be different, okay? And there you have it. That is the lesson 9.2, which is all about reflections. I do want to point out the properties of reflections because I didn't quite make it clear with the translations. The properties are what changes and what stays the same, which is something I mentioned a few times in this video already. So there you have it. Have a great day, and thank you again for watching this video. Have a good day.